Okay. A structure may be subjected to loads, forces, and pressure. So when you want to design what the suitable footing used, you have to check on the factors. For example, the dead load, and then the live loads, wind load. For other than that, is the earth pressure. Do you have a extra loading on top of it? So these are the things that you need to look at carefully before you can go to further judgment or decisions. Okay, what are the factors in the design shallow foundations? So these are very important for you to understand. In order to design the shallow foundations, you have to check on the adequate depth, and then limiting settlement, and then lastly is a factor of safety against a shear failure. So all these can be referred or can be complied to the Euro Code 7s, or it can be suited to the British standard. So somehow the footing, as I said lah, it can be designed according to the BS or according to the Euro Code 7 for geotechnical design. So you have to check what's the requirement from the client or from the consultant or from the contractor whatsoever to have this kind of the building design or structure, building design and construct. So the adequate depth must be sufficient to prevent any adverse effect due to changes in surface conditions. For example, climate changes, actions of freezing and thawing, temperature changes. So it is also important when dealing with horizontal loads or strong overturning moments. Okay, how about the limiting settlement? The limiting settlement is something that we try to give a limit, the allowable settlement that can be tackled by the footing. For example, we need to look at the total settlement, the differential and angular distortion, and also it is depending on the functional performance of the building and the requirement of the user as well as the economic factors. So I am not sure if you have heard on the settlement. So what is the difference when I said total settlement, the differential settlement, and also the angular distortions. So later on, when we go to the next part of the series for topic 2, you may see what is the settlement it is and how many settlement types that we have, just to make sure our design or the shallow foundation is safe to be used. And the next factor is a factor of safety. So whenever you design whether shallow or deep foundations, it's very important to check on the factor of safety. It is the conditions where the shear failure occurs when the soil divides into separate blocks or zones which move fully or partially and tangentially with respect to each other. So the factor of safety is by definition the ratio of the shear strength of the soil to the maximum mobilized shear stress must not be less than the appreciated value. So this is when you see the factor of safety in whatever geotechnical design applications, you have to meet the design FOS set number. For example, if you are designed for slope stability applications, so there's some standard FOS that you must meet too. For example, the stable slope must more than 1 or equal to more than 1. And then for footing, for example, it can be recommended to have the factor of safety around 2.5 to 3. So these are the things when you want to see that whether your structure or whether the soil can carry the load from the structure by having the factor of safety. If you calculate and then you get the factor of safety less than 2, for example, as stated in the standard, so you have to redesign. What is meant by redesign? You can change the size of the footing itself, for example. You can change the footing type, for example, from having a strip footing to rectangular or square footing. You may not change the soil profile or soil parameters because that's what we have got from the site investigation. So you may change the design itself to ensure we have the correct factor of safety as stated in the standard. Okay, these are the things that it says that the limiting settlement, for example, sand, the maximum total settlement, it is allowed for 40 millimeter only for isolated footings. And then maximum differential settlement between the adjacent columns, it is limit to 25 millimeter. Whereby we have clay for the maximum total settlement with a 65 millimeter for isolated footings, and we have maximum differential settlement between adjacent columns is 40 millimeter. So the good things about this one is that it is also can have the same meaning to the factor of safety. If you can check, if you can calculate the settlement is then in the number of the value stated here, so you can say that the factor of safety is a meet to the standard of requirement. However, when you calculate the settlement, you estimate the settlement, but then you have more than stated here, more than 40, more than 50 for example, or more than 30 for maximum differential settlement. So you also may have the FOS not meet to the standard or requirement. Okay, since we want to have the design, one of the requirement is the factor of safety against the shear failure. So you have to know what is the shear failure and what are modes of the shear failure. So for this particular things, we have three different modes of shear failure. So the factor of safety against the shear failure accordingly to the general failure, local shear failure, and lastly is a punching shear failure. So what is all about? If you look at to this figure, for example, from the left side of this figure, figure A, figure B, and figure C, so you can see that the pattern of the failure for each figure, general shear failure, local shear failure, and punching shear failure are totally differences. For example, the general shear failure here, you can see that how the soil will be changed beyond the ground surface, for example. So the general shear failures occurs when a clearly defined plastic yield slip surface form under the footings, so develops outward towards one or both sides and eventually to the ground surface. So the failure is sudden and will often be accompanied by severe tilting, leading to final collapse on one side. So this mode of failure is associated with dense or over-consolidated soils of low compressibility. So you akan nampak, once we apply loading on the ground surface, you can see that the structure is moved downward. So it is created some bulking outwards from the ground surface. So this is the kind showing to you the plastic zone and occur for the dense or over-consolidated soil or over-consolidated clay. So this particular failure occur for this particular soil, for example, dense and over-consolidated clay. Whereby, if you look at to the local shear, and you can see right now is much different compared to general shear failure. Don't forget, if you plot the settlement versus load, you can see how it is act by meaning the load increase, the settlement also increase by the increase of the load. And this is how it is. But when you have a local shear failure, it means that if from the top one, we can say that we have a good soil profile in terms of the dense and also the over-consolidated clay. The soil profile is good. Compared to the second one, local shear failure, you may have less or the weak soil profile compared to the general shear failure. So the local shear failure is occur in incompressible soils. Significant vertical movement may take place before any noticeable development or shear planes occur. As the soil beneath the footing reach the yield condition, the shear planes develop but fail to extend to the ground surface. And some adjacent bulging may occur, but very little tilting takes place. So the settlement which occurs will usually be principal design criterion. So you can see from here, it says that the tilting or the bulging very little compared to the general shear failure. And somehow, if you look at the comparisons on the top of the general shear failure, we can see that the bulking move outward from the ground surface. However, from the local shear, we couldn't see very clear. And for the punching shear, what we can have here in the weak compressible soil, considerable vertical movement may take place with the development of slit surface restricted to vertical planes adjacent to the side of the footing. So the bulking at the surface is usually absent and may even be replaced by drag down. So this time around, for punching shear, there is no bulking. However, there will be prone to have a drag down. You can see that how it is the plastic zone might differ to the local shear and general shear. And then also the failure mode for this one is is totally depending to the soil type. For example, if you have a sand, whether you have a dense sand or loose sand, or clay, for example, you may have a normal consolidated clay or you may have over consolidated clay. So all these general modes or local shear mode and punching shear modes are tested or were tested in experimentally and proven, showing the pattern of the failure. Okay, how to decide the FOS number? So these are some suggestions for you to have what speaker structure for particular certain FOS value. So this one, I think that you may need some time to go through, or just something that most practice used FOS from 2.5 to 3. Somehow it can be used as a 2. So what's important points that you may have from here is that the dense soils fail along well-defined slip planes, resulting in general shear failure, as stated just now, where loose soil do not fail sudden and the slip planes are not well defined, so resulting in local shear failure. And then very loose soil can fail by punching shear failure. So you can see how the soil profile change from the dense to the loose and to the very loose give to you the idea what's the mode of the shear failure. The more suitable is expected in loose soils than in dense soils. So the expected failure surface for general shear failure consists of rigid wedge of trapped beneath the footing bordering radial shear zones under rankings and passive zones. Okay, that's on the shallow. Now we want to see what's the theory behind the shallow foundations concept, or the concept for shallow foundations, and how we can calculate the ultimate and allowable bearing capacity for the shallow foundations. So first of all, you have to know or to understand the definition, what is the ultimate bearing capacity and what is the notation symbol that represent for each one of these. So the ultimate bearing capacity, QF, is the intensity of bearing pressure at which the supporting ground is expected to fail in shear. So just now tadi kita dah tengok kan ada 3 jenis shear failure, sama ada footing fail in general, local ataupun punching shear failure. But how to go to that kind of mode of failure without knowing what is the bearing capacity? So you have to calculate the bearing capacity and then check the factor of safety, then you can conclude the failure of the footing. Okay, what is the net ultimate bearing capacity? So the net shows by symbol Q and F. So you have to differentiate between ultimate bearing capacity and the net ultimate bearing capacity. For ultimate bearing capacity, we just take it as a QF, whereby for net ultimate bearing capacity is a Q and F. So what is the difference between these two things? The QF is the ultimate bearing capacity, where the net is from the ultimate bearing capacity, you have to minus with the overburden pressure. So what is the overburden pressure? The overburden pressure is knowing as what? Gamma times dengan T. That is the overburden pressure. Okay, at the bottom here is also some notations indicate to you some symbols for net bearing pressure, and etc. Okay, the next one is the net bearing pressure, QN. Net foundation pressure or the net loading intensity. It is the net change in total stress experienced by the soil at the base of the foundations. So the difference between the total applied stress Q and then the stress removed due to excavations sigma naught as known as the QN, or we call it as the net bearing pressure. Okay, what is the Q? Q is the contact pressure at the base of the foundation. So, the Q is calculated from the P over A. P is the loading ataupun kita panggil kat sini sebagai design load transferred from column. So, some symbol or some question use symbol P or some symbol use symbol Q. So, it is the contact pressure. So what is the sigma naught? Sigma naught is the overburden pressure adjacent to the foundation or pressure relief due to excavations. For example, just now one of the factors for design shallow foundation is the adequate depth. So for this one, the D is we call as the embedment depth. So the footing can be placed on the ground surface or few meter below ground surface, or we call it as the embedment depth. So how to calculate the overburden pressure sigma naught? Is the gamma times with the D. That's how you can get the sigma naught. So the sigma naught is at the bottom of your footing here. So that is the sigma naught. Okay, there's some conditions for the sigma naught. You need to check closely whether it has the groundwater table effect or it doesn't have any groundwater table effect. So that will be explained later on. Okay, what I just explained gamma times T if you do not have any groundwater table effect. So the overburden pressure at the base of the footing can be calculated as the gamma times with the T. So we want to check the net bearing pressure in terms of the effect from the contact pressure from the design load of the column with the overburden pressure. The next definition that very important in the topic 2 is the factor of safety. So the factor of safety is defined as the ratio between the net ultimate bearing capacity and the net bearing pressure Qn. But this formula can be differ according to the author purpose or research purpose from the past theory or from the past concept. So you may see later on some formula for the factor of safety is not like this way lah. So you can see how it is. And the next one is a presumed bearing value. It's a conservative value to a rock or soil and preliminary design purpose. And it is empirical data, consideration the width of the foundations, the proper settlement limits and local experience. So these are 4 important definitions. And don't forget to the last one is the allowable bearing capacity. So what is the allowable bearing capacity QA? So the bearing pressure that will cause either undrained or drained settlement or creep equal to a specified tolerable design limit. Just now in the early lecture, I have shown to you the tolerable limiting settlement for some kinds of sand, footing on sand, footing on clay. So that's some idea how we can use to design or we want to see, for example. So the allowable design value for the applied bearing pressure must satisfy the 2 criteria. For first criteria is an ultimate limit state value, which is the shear strength, and the second criteria is a serviceability limit state value, which is a settlement. Okay, what is the ultimate limit state value or the shear strength ataupun the first criteria for allowable bearing capacity? So the allowable bearing capacity, or somehow they can call it as a safe bearing pressure, is equal to the ultimate bearing capacity QF minus overburden pressure over factor of safety plus with the effective overburden pressure. Here also effective overburden pressure, or it is depends to the intensity of the pressure of the footing whether you have the effect of groundwater table or you don't have the effect groundwater table. I mean that is it the footing influenced by the groundwater table effect. So you have to check how to calculate the effective overburden pressure. For the second criteria, to calculate the allowable bearing capacity that we must satisfy with is the serviceability limit state value or the settlement. This is the calculations for immediate or undrained settlement. The allowable ataupun kita panggil dia sebagai safe bearing pressure is a SL times EU over B times 1 minus Poisson ratio power of 2 times with the influence factor plus dengan overburden pressure. Or you have the effect of consolidation settlement ataupun kita panggil dia sebagai drain settlement. So this is the formula. So look at to the questions, and some question may not say anything. It must satisfy from shear strength or it must satisfy from settlement. It just say that calculate the ultimate bearing capacity or calculate the safe bearing capacity. So you can use the general equations for the shear strength only. If it is stated that it must satisfy with the criteria number 2, the settlement effect. So this is how it is to calculate the QA. Okay, the ultimate bearing capacity also satisfy to the assumptions made by Terzaghi. So the Terzaghi is a very well-known researcher in the soil mechanics. So if you search on the Terzaghi from Google, so there's a lot of information that you can see or you can have to read on. So what are assumptions made by Terzaghi? Terzaghi says that the soil is a semi-infinite homogeneous, isotropic, weightless and rigid plastic material. So why it is assumed this way? Because it tries to make that calculation on ultimate bearing capacity or whatever in the easiest way. And then the embedment depth D is not greater than the width of the footing. So DF must less than the width of the footing B. So it assumes the general shear failure occurs. So the failure zone angle, as I said just now, below the footing, it can create a plastic zone or the failure zone. So the failure zone angle alpha F is equal to internal friction angle effective. However, later work has shown by Visick that the failure zone is not equal to internal friction angle, but it is 45 plus phi over 2 to be more realistic. So you can see at this figure below, this is how it is derived that the failure zone angle or the plastic zone angle is equal to the 45 plus phi over 2. Okay, the shear strength of the soil above the footing base is negligible and it is considered the shear above the footing base. So the soil above the footing base can be replaced by surcharge stress, gamma D, and the base of the footing is rough. Okay, please listen carefully. This is very important to calculate the ultimate bearing capacity formula QF. So what is QF as I explained just now? So the QF is the intensity of the bearing pressure at which the supporting ground is expected to fail in shear. Sama ada general ke apa kan. So dalam QF ni consists of three terms. The first term is cohesions, second term is a surcharge, and the third term is to the unit weight of soil. So what is the QC? QC is a C times NC, and then from the second term is on the surcharge, or what we call it as a overburden pressure effect. So the overburden times with the NQ, and the third term for unit weight is a half times B times gamma times N and gamma. NC, NQ, and gamma are bearing capacity factors. So it is taken by example if you want to calculate ultimate bearing capacity for straight footing. So you akan nampak lah the full formula is a CNC plus overburden pressure NQ plus half B gamma N gamma. So ada term 1, term 2 dan juga term number 3. Okay, the NC, NQ and gamma are bearing capacity factors are depending on the angle of the soil. So nothing to worry because you can refer from table or from question. It's already given to you all these three values. So you just use properly to what type of the footing you have in the questions. Okay, for example, kalau tadi kita dah tengok strip, first term dia CNC ni, kalau depan ni dia tak ada apa-apa number kan. So kita kata dia satu lah. Faktor dia satu. Kemudian second term dia tak ada apa-apa perubahan. Overburden pressure times dengan NQ. Okay, third term for effect unit weight. So please be careful. This will be changed accordingly to the footing type. Kalau strip, third term kat sini dia akan jadi 0.5. Tapi kalau untuk circular, first term strip kita ada satu kan, circular kita akan ada 1.3 CNC. Second term maintain, third term dia akan guna 0.3 B gamma and gamma. For square is a 1.3 CNC, second term is maintain, and then third term will be 0.4 B gamma and gamma. And then for rectangular, CNC times 1 plus 0.3 times B over L, second term maintain, and then this is the formula for third term. So please be careful when you want to analyze or when you want to calculate the ultimate bearing capacity of the footing. So read question carefully, what footing that you need to have the QF. So, kalau kata strip, so kita boleh guna straightforward lah formula ni CNC. Tapi kalau dia circular, 1.3 CNC plus overburden NQ plus 0.3 P gamma and N gamma. Okay, we go to the next effect groundwater table. Okay, apa effect groundwater table? Groundwater table mostly affected to the term number 2 and also term number 3. Okay, if you have a textbook, you can refer from the textbook page 457 to the next 500 example. That's how ideal for you to have the calculation QF. Kemudian macam mana nak tengok the effect water table. Okay, at the ground surface, kalau kata footing you berada pada ground surface, so kita punya overburden pressure is a effective gamma times dengan D. For these particular things, kalau you look at to the first one, at ground surface here, okay, at the ground surface. Okay, it says that if you have water table at the ground surface, so this is the case number 1. Okay, the changes will be affected to the unit weight. Unit weight kita akan pakai effective unit weight yang mana gamma saturated minus dengan gamma water, barulah you darab berapa kedalaman footing tu berada daripada permukaan tanah. Similarly for term number 3, nampak tak kat sini kita ada gamma kan? Gamma kat sinilah yang akan terkesan bila you buat calculation for term number 3 bila you have water table effect at the ground surface. So now you kena pakai effective gamma saturated minus dengan gamma water. So mostly gamma water kita akan ambil 9.81 lah. So lebih kemas kita pakai 9.81. So I don't want every one of you ada yang guna 10 lah, ada yang guna 9.81. It must be use 9.81 sebab dalam sini pun dia dah kata if there is an upward component of seepage flow of hydraulic gradient R, the effective unit weight must be further reduced by an amount equal to the HW, which is 9.81 kN per cube meter. So siapa yang guna 10 kN per cube meter, saya akan reduce mark. So please 9.81 adalah value untuk gamma water. Okay, what is the effect kalau kata groundwater table tu berada beberapa meter from the ground surface? So at this time, you akan nampak at the upper zone of the soil here will be in the dry situations ataupun bulk conditions, whereby soil below groundwater table will be affected or we can have a gamma saturated. So for this particular time, how to calculate second term for the effect of overburden pressure? So overburden pressure as I said at the base footing kan, so kita nak calculate overburden pressure at base footing sini. So dia punya pressure dia mesti counted from the top to the bottom of the footing. So apa yang terkesan adalah you kena ambil gamma bulk dekat bahagian above water table darab dengan ZW plus dengan effective unit weight below the ground water table times dengan HW. So I hope that you can see the changes antara kes pertama dengan kes kedua tadi. Kes pertama tadi dia akan pakai fully D. Sebabnya apa? Sebabnya kita punya tanah ni memang dah fully saturated from the top to the bottom of the footing. So we calculated directly as the effective gamma times dengan D. For this particular condition too, intermediate, the groundwater table at the intermediate, so dia akan ada dua depth, ZW dengan HW. HW for effect by water table, ZW dalam keadaan dry or bulk. How about the term 3? Term number 3 ni, kita nak tengok effect of the unit weight at the base footing. So you akan tengok pada base footing kat sini, pada condition number 2, base footing kita dalam keadaan dry ke wet? Any answer?
Dry.
Are you sure? Who is answer? Haris, is it dry? Okay, look at closely ya. Okay, untuk kes nombor 2, yang mana water table kita berada beberapa meter daripada permukaan tanah, tapi kan footing kita ni dia berada dekat bahagian mana? Bawah sekali kan? Maknanya air di sini, footing kita kat sini. So footing kita dalam keadaan dry ke wet?
Dalam keadaan wet.
Okay, good. That's why term number 3 untuk unit weight ni, they will be affected by water table effect. So that's why kat sini gamma effective adalah gamma saturated minus dengan gamma water. Same goes to condition number 1. Okay, condition number 1, water table kita ni berlaku daripada atas. Maknanya foundations ni is fully saturated. So we want to calculate term number 3 in the terms of the unit weight. You akan nampak kat sini base footing kita ni dekat bahagian bawah kan? Water table kita dekat atas kan? So base footing kita dalam keadaan wet ke dry?
Wet.
Yes, that's why kat sini gamma kat sini adalah gamma efektif. Kenapa saya tanya soalan ni? You akan nampak following cases yang mana ada conditions number 3, condition number 4 dan juga condition number 5 yang effect number 3 term ni gamma dia adalah gamma biasa. Dia bukan lagi gamma efektif ataupun gamma saturated minus dengan gamma water. Okay, kalau you tengok gamma untuk case number 3, at base of foundation within B depth ataupun kita panggil sebagai above passive zone. Okay, dalam case ni untuk term number 2, water table kita dah tak ada kesan dah untuk overburden pressure. So ini conditions yang mana air tu dah berada pada somehow in this area zone. So kita boleh kata overburden pressure kita dalam keadaan dry. That's why overburden sigma naught kat sini dia bukan lagi gamma efektif. Dia adalah gamma biasa. You can use gamma bulk ataupun you can use gamma dry according to the information given to you. That's why sigma naught kat sini bukan lagi sigma efektif. Dia adalah total sigma. Sigma efektif yang mana you kena tolak dengan unit weight of the water. Kalau kata sigma biasa ni, dia tak akan ada effect water table. But bila you pergi term number 3, since dia masih lagi berada dalam zone influence of the water table, so gamma dia masih lagi gamma efektif. Tapi kalau conditions yang mana awak punya water table ni above the passive zone, term number 2 masih lagi biasa, dia bukan lagi efektif unit overburden pressure, tapi dia akan ada perubahan dari segi calculation untuk effective unit weight. So dia punya formula jadi expand sikit lah, dia dah tak boleh pakai gamma saturated minus dengan gamma water. It may change to the gamma saturated minus gamma water times dengan 1 minus dW minus dF over V. Sebab kita nak tengok the influence of the zone kat sini. Active zone ke ataupun below or above the passive zone. We want to see that things. Ni nampak dash line ni, ini adalah passive zone. Kita nak tengok dia berada dekat bahagian atas ataupun dia berada di bahagian bawah. Kalau kata water table effect tu berada di bahagian atas passive zone, so gamma saturated dia mesti kira macam ni. So case nombor 4 lah. Kalau kata water table kita berada di bawah passive zone, so sekarang ni awak punya term number 2 pun is a normal overburden pressure without water table effect. Similarly to the term number 3, iaitu gamma dia kita akan ambil sebagai gamma bulk ataupun gamma dry. So please be careful on that particular effect of the water table, water pressure load ataupun groundwater table effect. So I hope this one is very clear lah. If the groundwater is below the foundation level and above the passive zone within the depth B below the foundation at position 4, the effective unit weight for term number 3 will be changed to this formula. So you kena pakailah formula. Untuk maklumat juga, ada setengah formula yang dalam test tu kita akan bagi pada awak. Tapi awak sendirilah kena tahu kan, banyak-banyak formula ni mana yang sesuai untuk guna kan. Soalan yang mana, jangan main salah gunalah. So maksudnya bila you baca tu, you nak buat revision tu, you kena betul-betul faham, bukan menghafal sahaja tanpa you tahu tujuan dia kat mana. Oh ni chapter berapa. Bila you faham soil mechanic, you faham geotechnic, there's something that dia akan carry on daripada past course yang you ambil soil mechanic sehinggalah you bawa kepada geotechnic. The only thing is that dalam geotechnic ni, dia adalah application kepada soil mechanic yang you have learned. Soil mechanic is on the basic fundamental. But now in geotechnic, how do you apply the basic fundamental of the soil mechanic into the geotechnic dengan cara apa? You nak buat design, you nak buat calculation for design. For today example, contohnya kita nak menggunakan soil parameter daripada soil mechanic, chapter 1 daripada geotechnic untuk you calculate ultimate bearing capacity for example kan. So this is how it is. So dia tak adalah kata first time baru nak jumpa overburden pressure sigma naught, baru nak tahu apa tu sigma naught. No, it's not that way. It's very important because as I said, kalau kata you salah faham konsep on the overburden, sama ada total ataupun effective, dia akan bagi you wrong calculations, wrong answer. And then the calculation will be affected from the top to bottom kalau dia bersaling kait antara satu sama lain. It's very important to understand the effect of the groundwater table, macam mana kesan dia pada second term, macam mana kesan dia pada third term, kemudian the depth, embankment depth tu kita nak ambil mana ke mana, what is the net intensity, and then what is the net pressure, all the definitions tu dia ada kaitan dengan calculation. Okay, just now I said untuk NC, NQ, and gamma ni dia akan bagi you table. Table tu pula bergantung kepada fee awak. Maknanya kita nak dapat NC, NQ, and gamma ni bergantung kepada jenis tanah. Kalau kata footing you laid on sand, so maknanya kita tahu dalam sand properties ni sama ada loose sand ke dense sands ke, dia akan ada friction angle. So the fee from 1 ataupun sehinggalah 50. Contoh kalau kat sini mungkin awak tak berapa nak jelas lah. Saya boleh besarkanlah secara general. Kalau kita nak tengok bearing capacity factors for all terms 1, 2, 3, NC, NQ, and gamma, you boleh tengok daripada table A lah contohnya. NC ni faktor untuk term 1, NQ term number 2, and gamma term number 3. Kalau kita ada fee is 29, so NC is a 27. So yang ni kita punya NC. And then kita punya NQ adalah 16.4 and gamma kita adalah 15.4. Kalau kata your strip footing is laid on clay, so kalau dia berada atas clay, so dia tak ada masalah apa. Sebab kita tahu clay, kalau kita ambil yang pure clay ni, the fee is equal to 0. So kita nak ambil NC berapa? 5.14 and gamma is a 1. NQ is 1 and gamma is a 0. So that's how you can get the factors of the bearing capacity. Kalau kata it mentions that all these factors table from Komboja for example kan, so you kena tengok the right tables lah, jangan salah guna. Kalau dia kata dia menggunakan modified bearing capacity factor, so this is the right table untuk you refer. Okay, itulah yang nak nak tekankan. Okay, sekarang kita pergi calculations ultimate bearing capacity. Macam tadilah saya cakapkan, we go to the major classification of soil, sama ada kita ada sand dengan gravel ataupun kita ada clay and silt. So maknanya sand and gravel one group for coarse, kemudian second group for fine is the clay and silt. So the ideally is that you can say how to differentiate these two major groups dengan tengok pada soil properties. The easiest way is that kalau coarse soil ni, kita akan kata C dia kosong. Tapi dia punya phi, internal friction angle, tak mungkin sama dengan kosong. So the bearing capacity calculation should be carried out in terms of effective, and the previous equation becomes, so you akan nampak lah kan, tadi kita calculate dia sebagai total. Right now dia dah jadi effective. Semua ada prime. Semua ni atas ni ada prime. Semua ni akan ada prime. So what is SQ, S gamma, semua ni? Dia adalah shape factor. Shape factor kepada footing types. Kalau kata strip, dia punya shape factor berapa nilai dia. Kalau you ada square footing, shape factor dia berapa. Okay, remember just now, kalau dia hanyalah QF, so kita hanya ada term number 2 dengan term number 3. Okay, ingat tak tadi saya kata kalau ikutkan formula strip footing, kita ada term 1, term 2, term 3. Tapi itu general statement yang dia tak bagi tahu footing awak duduk kat mana, sand ke, gravel ke, clay ataupun silt. But then if we say that the footing, the strip footing is laid on the sand, so you akan nampak kenapa term number 1 ni kosong. Ataupun dalam formula ni term number 1 tak ada, dia tak wujud, hanya ada term number 2 dengan term number 3. Because C dia sama dengan kosong. So kita tak perlulah kira ataupun tak perlu tulis pun tak apa. Okay, then kenapa dia minus dengan effective overburden pressure? Because dia adalah net. Remember kalau saya hanya sebut dia sebagai ultimate bearing capacity, so yang belakang ni tak perlu. So kita tak payah, kita buang dia. Tapi kalau dia kata dia adalah net ultimate bearing capacity, so you kena tolak dengan overburden pressure. So overburden pressure ni bergantung kepada footing awak. Ada tak effect water table? Kalau dia ada effect water table, so kita akan ambil effective gamma. Kalau tak, kita akan ambil calculation biasalah. Okay, ini yang saya maksudkan, yang mana dia adalah ultimate bearing capacity yang bukan sebagai QN. Yang ni QF. Kalau QNF, dia tolak dengan overburden pressure. Kalau QF, formula tu berhenti sampai term number 2 dengan term number 3 saja. Macam ni ya. So however, the values of effective gamma changes depending on the positions of the groundwater as given in the previous slide. Okay, if you have a footing laid on the fine soils, so dalam this case, you akan nampak term number 3 sama, dia akan hilang lah. Sebab dalam case tu, contohlah kita ambil phi sama dengan kosong. Kalau kita refer table sebelum ni tadi, phi sama dengan kosong, NC 5.14, NQ1, N gamma kosong. So betul lah kan yang ditulis kat sini, NQ1, N gamma kosong. So bila kita masuk dalam formula balik, untuk fine soil, kita akan ada CU, NC dan juga effective gamma. Effective gamma ni, kalau you ada some value, so kita calculatekanlah NQ sebagai 1, CUNC kita gantikanlah nilai undrained coefficient berapa, NC sama dengan 5.14, N gamma sama dengan kosong. That's why term number 3 tu tak ada sebab N gamma kita kosong. So kalau you calculate untuk net ultimate bearing capacity, dia hanya tinggal akhir sekali adalah CUNC. Kenapa hilangnya CUNC? Kalau you tengok tadi kan, ultimate bearing capacity QF is a CUNC plus dengan gamma efektif darab dengan D. Kenapa bila kita nak calculate dia sebagai net ultimate bearing capacity as a Q and F, dia hanya tinggal CUNC? Sebab daripada Q and F, kita akan dapat Q and F sama dengan QF tolak dengan overburden pressure. So overburden pressure kita tadi efektif darab dengan D. That's why plus gamma D tolak efektif gamma D, so dia akan bagi you kosong. That's why finally Q and F sama dengan Cu and C. Okay, the values of NC may be obtained from the chart shown just now. Okay, ini kalau kata you nak estimate ultimate bearing capacity for undrained condition untuk tanah jenis silt ataupun clay. Yang ni dia bagi dalam bentuk chart maknanya you have to refer careful, read question carefully. Dia nak minta you calculate ultimate bearing capacity according to the which formula. Adakah terzagi formula, basic formula ataupun Meyerhof ataupun Skempton's formula. Kalau Skempton formula ni selalunya dia akan bagi you a graph. A graph untuk you obtain the NC value. NC value ni pula bergantung kepada ratio D over B dan juga B over L. B over L ni semua is referring to the shape. Kalau kata B over L sama dengan 0, so kita tahulah straight footing. Ataupun dalam soalan tu kata it is laid the straight footing laid on silt soil. So you dah tahulah you nak pakai B over L kosong ataupun B over L sama dengan 1. And then how about D over B? Sebab kita nak dapat NC ni kan. So kita kena adalah maklumat jenis bentuk footing tu apa jenis dia. Kemudian D over B tu berapa nilai dia. For example, if you know that the footing is a straight, kemudian D over B is a 2. So you boleh tarik lah pergi sini and then you pergi ke sini. So kita estimate lah, let's say kita dapat 7.2 something. That is the NC value. D is the founding depth ataupun embankment depth. B is the width of the footing. Okay, dia bagi juga some notes. The maximum value when D over B is more than 4. So kita kena pakai these kinds of the NC lah. Straight footing kalau dia B over S sama dengan 0, so NC is 7.5. And then for square or circular footing, NC mesti sama dengan 9. This is apply kalau D over B more than 4. So you kena pakai this one lah. Okay, net bearing pressure is tadi capacity tau, net bearing capacity. Now is the net bearing pressure. Net bearing pressure pun tadi saya dah explain dia berkaitan dengan contact pressure Q dengan overburden pressure kita. So kalau net bearing pressure Qn is equal to Q minus dengan overburden pressure. The Q here is referring to the contact pressure at the base of the foundations. Yang mana design load. Design load daripada kolom tu berapa? So kalau kata design load column is 500 kN and then you know the footing type ataupun the footing size. For example, kalau you ada square footing, so you boleh dapatlah contact pressure kan 500 kN bahagi dengan 3/3. Contohlah kan size footing tu 3/3 sebab dia square. So you dah tahu contact pressure. So in order to calculate net bearing pressure, contact pressure Q minus dengan overburden pressure. Overburden pressure ni is depending to the effect surcharge lah, stress effect ataupun surcharge effect. So dia bergantunglah sama ada original state ataupun ada some excavations or constructions and the loading. So you nak cari stress effect tu at which particular stress point depth. D ni dia referring to that one. Okay, ultimate stability design for shallow foundations. So kita ada lagi formula lain daripada De Beer and also Versick. This formula you can see that dia ada satu lagi faktor tambahan yang mana saya sebut tadi as a shape factors, SC, SQ and S gamma. So all that SC, SQ and S gamma ni pun dia dah bagilah kalau you have different footing strip ke, rectangular ke ataupun circle or square. So read question carefully. You are required to calculate ultimate bearing capacity to which particular theory or formula. Okay, the shape factors also can be obtained from the Meyerhof ataupun Hansen. It's quite complex lah, but I think that if you have your own time, look at closely what is the shape factor kalau from Meyerhof kan. Kemudian dia punya conditions dia sama dengan ataupun lebih daripada 10 degree. Kemudian kalau lower than phi tu value, kita nak ambil SQS gamma berapa. And then kalau Hansen ni dia lebih kepada Hansen pun sama juga, dia ada inclination factors, dia ada depth factors, and then dia ada juga shape factors. So look at to that particular information given to you, which one yang you nak kena follow untuk buat calculations. Okay, yang tu pasal factor of safety. Tadi pasal apa tu? Ultimate bearing capacity. So factor of safety yang ni pun saya dah explain daripada awal tadi. Cuma macam saya cakap lah, factor of safety ni sebenarnya kalau you tengok closely okay, in summary lah yang berkaitan dengan bearing capacity. Which bearing capacity equation kita nak guna? Kita nak guna Terzaghi ke? Kita nak guna Hansen-Versick ke? Kita nak guna Hansen-Meyerhof. So it just give you quick view how to make decisions on that particular things lah. Both suggest or recommended this way. Atau lebih mudah dalam soalan selalunya dia dah stated dah. Okay, use the Terzaghi formula to calculate the ultimate bearing capacity. Ataupun Hansen or Versick etc. Or looking back, looking at the appendix pun you dah tahu apa sebenarnya teori yang kita pakai. Contohnya kalau Terzaghi, very cohesive solve where D over B less than 1 for quick estimate of QF to compare with other methods. So do not use for foundation with moment and or horizontal forces or for tilted base and or sloping ground. So nampakkan tadi Terzaghi ni dia tak ada effect inclination factor. So kalau you ada footing yang incline, it's not vertically stand, dia incline few angles, so memang sasar Terzaghi tu tak sesuai kan. So you kena pergi ke Hansen ataupun Versick or Meyerhof yang mana dia ada inclination factors. So Hansen Meyerhof Versick ni is any situation that applies depending on user preference or familiarity with a particular method. Okay, ni caralah macam mana you nak tentukan. Okay, untuk safe bearing capacity ataupun allowable bearing capacity dia ada beberapa formula yang you boleh tengok contoh kat sini Kalau kata Whitlow dalam textbook dia estimate allowable bearing capacity ataupun allowable bearing pressure sebagai QNF over FOS plus dengan gamma D. Ada setengah yang ambil sebagai QF minus gamma D over FOS. Maknanya in order to calculate the net bearing pressure ni dia akan ambil net ultimate bearing capacity bahagi dengan FOS. So bila sebut net ni maknanya you kena tolak antara ultimate bearing capacity QF tolak dengan overburden pressure. So itu untuk net. Kalau allowable, this is how it is calculated. Okay, ada perbezaan yang mana setengah buku dia menggunakan allowable bearing capacity tu sebagai Q ultimate QF bahagi terus dengan FOS. Tapi jarang-jarang sangatlah benda tu diguna pakai. Yang selalu kita akan jumpa these things lah. Safe gross bearing pressure you have to calculate dengan cara QNF bahagi dengan FOS plus dengan gamma D. Itu yang formula yang you kena follow. Ini yang saya kata kalau macam belajar MDAS ni dia ambil simplest way ataupun kita sebut sebagai conservative calculation on the ultimate bearing capacity Q allowable. Yang mana dia ambil QF bahagi dengan FOS. So dia akan bagi you overestimate lah nilai Q allowable. Itulah perbandingan kalau you pakai secara direct calculation here ataupun you ambil dia sebagai QNF bagi FOS plus dengan overburden pressure. Whether you have overestimate ataupun underestimate. So dia tak ada kata oh this is wrong or this is right. But you have to follow exactly lah apa information yang diberikan dalam soalan. Okay, yang ni saya akan KIV dulu sebab saya akan guna for the last remaining. So saya nak pergi lagi dua types of settlement. Yang ni saya akan make it a speed explanations lah. Sebab kita ada lagi satu subtopik untuk theoretical. Actually dari learning activities pun you dah tahu apa yang you akan dan dah belajar daripada kelas online Okay, definitions on settlement. Settlement ni, as I explained, is a vertical downward displacement at the base of the foundation or other structure due to the ground movement. So bila kita kata total settlement ni, it consists of immediate settlement, primary consolidation and also the secondary settlement. So if I'm not mistaken, in the soil mechanic ni, you have learned on the immediate, primary dan juga secondary, how to determine or estimate the region of the immediate, primary dan juga secondary settlement. So I will not explain further. Okay, what are factors ataupun jenis-jenis foundation settlement? Kita ada uniform settlement yang mana there is no crack, ataupun kita ada tipping settlement, often without cracks also. But the last yang very crucial settlement ni yang menyebabkan crack terlalu besar, kita panggil dia sebagai differential settlement. So apa perbezaan antara setiap benda tu, uniform settlement dan juga differential settlement? So you boleh bacalah, antaranya occurs at nearly the same rate throughout all portions of building. Itulah sebab kenapa kita panggil dia uniform settlement. You akan nampak dia punya perbezaan on the left or right sides of the settlement building dalam same amount. Tapi kalau you tengok pada differential settlement, you can see that dia some kinds of the incline movement on the left side dengan right side, dia punya vertical displacement bukan value yang sama. So that is the differential settlement. You nak tengok berapa difference. Is it small ataupun big difference? Okay, selalunya for differential settlement ni, 20 mm differential settlement is the conventional buildings with isolated foundations. Dia punya limiting value lah. And then for total settlement, for the tolerable seam structure is allowed for 50 mm. So what are causes? So the causes of the settlement, for example, the weight of the building. So yang ni pun saya ada explainkan faktor-faktor untuk kita design foundation. So dia bergantung kepada live load, dead load ataupun earthquake or any other factors yang lain. So all that kinds that can give to you to the factor of the foundation settlement. Ataupun indirect causes. Indirect causes, for example, failure of collapsible soil, underground infiltrations, yielding of excavations ataupun earthquake. Okay, yang ni pun I will not explain further. Okay, settlement. Settlement can be estimated from theory ataupun from the field measurement. Teori ni macam saya cakap lah, you ada one dimensional consolidation test, kemudian you plot graph, you akan dapat immediate settlement, you tahu primary settlement, kemudian you akan dapat secondary settlement. So dia ada formula tertentu lah untuk you calculate settlement. Yang melibatkan field measurement ataupun field observation, for example, plate bearing test, pilot test, SPT, CPT dan juga Macintosh probe. Okay, serviceability limit state, ini yang berkaitan dengan settlement. So dalam kita nak design foundations ni, dia punya kriteria tu untuk calculate Q allowable, kita akan tengok pada shear strength dan juga settlement punya limit state. Okay, this is how we can estimate settlement lah. Settlement macam saya cakap lah, from the theory itself ataupun from field measurement. Okay, settlement ni bergantung kepada awak punya foundation juga. Tadi saya hanya explain kan, kita ada different type of foundations, dia punya shape, dia punya size kan. Other than that, dia bergantung kepada sama ada foundations kita tu adalah rigid ataupun dia adalah flexible. And also to the soil itself, soil profile, soil parameters, for example, Young modulus dan juga Poisson ratio, the founded depth EF dan juga H. Okay, immediate settlement, kalau daripada teori, this is what we can have, Terzaghi, Scampton, Jambu dan juga management from SPT ataupun CPT. So dia berbeza for type of soil, cohesive dan juga cohesionless. And for calculations or estimated settlement, immediate, you can have from the Terzaghi equations, from theory, ataupun you can also use from the Jambu method. So all those two formulas here, you have to need or know dia punya influence factor IP. Influence factor ni, dia also similar to that kinds of, kita panggil dia vertical changes lah, vertical stress. So kalau kata awak punya footing ni jenis flexible, kemudian footing you is located at the center, dia punya shape adalah circle. So dia punya influence factor is IP sama dengan 1. So kat mana nak guna IP? Masukkan dalam formula terzagi contohnya. Kalau awak nak kira terzagi, pakai formula terzagi lah kan. Okay, what is the alpha? Alpha can be found from this graph. Graph yang kat bawah ni pula. So macam mana kita nak pakai nilai alpha? Kita kena tahulah berapa ratio antara D square root B over L dan juga alpha dan juga nilai L over B. So kalau you tahu dua nilai ni, L over B, D over square root BL ni, so kita dah tahu the correction factor for foundation depth. Itu kalau you menggunakan terzagi. Same goes to the Jambu method. So Jambu method ni you kena tengok dia punya coefficient factor. Kemudian you kena tengok undrained modulus of elasticity dan juga B size. Okay, ini yang untuk Jambu lah. You kena ambil nilai nu1 dan juga nu2. Kalau you menggunakan field measurement, CPT, SPT untuk calculate atau estimate immediate settlement, this is the formula that you can use to have that kind of the immediate settlement. Okay, this is example if you have layered of soil profile and then you have the data from the CPT, so you can tabulate the data into this table and then need to know what is the total settlement for each layer so that it is represent to you the whole of this the picture of the profile. Maknanya kalau you tengok sini, kita ada data daripada cone resistance, we want to estimate the settlement due to this footing. So apa yang kita kena buat adalah kita kena calculate lah what is the IZ, kemudian you kena dapatkan EU modulus yang, undrained modulus yang pada setiap layer yang you dah pecahkan tadi tu. Kemudian berapa nilai cone resistance QC, influence factor dia berapa, lepas tu you multiply, baru you boleh dapat total immediate settlement. Okay, yang ni kalau you menggunakan consolidation settlement, kemudian you nak calculate total settlement, this is what I said, dia ada kaitan balik daripada chapter soil mechanics. So kita letak footing kita dekat center ataupun dekat edge of the corner. So you want to have what is the immediate settlement ataupun consolidation settlement. So you kena dapatlah dia punya influence factor. Influence factor darab dengan contact pressure, baru you boleh dapat the changes in the overburden stress. So apa tujuan you calculate the changes overburden stress ni? Untuk you masukkan dalam this formula, iaitu SC sama dengan CC over 1 plus E naught log delta stress plus dengan overburden pressure bahagi dengan overburden pressure times dengan H naught. Okay, ada juga kita estimate settlement from the plate bearing test. Okay, kalau plate bearing test ni you have to check lah this formula closely, sama ada plate bearing test on sand ataupun plate bearing test on clay. There are few assumptions or conditions yang you can follow to suit with the formula lah. Maknanya kalau kita nak guna formula tu, sebabkan dia SPT value kan, so SPT value ni dia represent the strength soil menggunakan N number, N value. So N value ni nak kena buat apa bila kita dah dapat? Is it need to do the correction ataupun kita can use straightforward the calculation the N value that we obtain from the SPT? Itulah dia punya few conditions lah bila you pakai this kind of the formula ataupun you pakai standard penetration test to estimate the settlement. Okay. Okay, for the estimations of the settlement, I also attach here in this slide. So I give it you time untuk have your own study lah. Okay, now we go back to the example for calculations ultimate bearing capacity. Okay, this is very important for me to explain because dari konsep atau teori tadi kita dah tunjuk few cases yang melibatkan water table effect. So kita nak tengok macam mana kita nak calculate the ultimate bearing capacity for different conditions, for different terms. Contohlah for example, one here, Okay, kalau you look at to these questions, you are given a square shape footing. Macam mana saya tahu square shape footing? Because the size footing is a 1.5 by 1.5 meter. So itu yang paling simple lah. Kalau dia bagi awak size footing kan. Sebab kalau you tengok kat sini, the question asks you a square of footing size of 1.5 by 1.5 meter is supported in a uniform deposit of soil. Given the soil information as here, calculate the ultimate bearing capacity allowable load using FOS equal to 4. Maksudnya sekarang kita nak dapatkan Q allowable lah dengan nilai FOS sama dengan 4. Okay, consider the groundwater table effect on all cases. Okay, dalam satu contoh ni, dia bagi semua case untuk effect water table. Okay, contohnya, contoh okay. Mula-mula you kena tahulah maklumat soil profile ataupun soil parameters. So dia bagi maklumat kat sini. Gamma sama dengan 17.8. Kemudian phi sama dengan 20. C prime sama dengan 15.2. FOS is 4. Kemudian kalau you tengok daripada tersegi bearing capacity factor from the table. So NC for 20. Phi for 20 degree. So NC sama dengan 17.7. NQ sama dengan 7.4. And gamma sama dengan 4.4. Okey, kita pergi ke case pertama kalau you ada textbook ke. Okey, case pertama yang mana okey, saya bagi gambaran dululah. Sebab tadi kita ada simple case yang very general, tak ada pun maklumat air tu kat mana kan. Dia hanya bagi footing size apa semua Okay, P is the design load transferred from column. Okay, case pertama yang mana water table dekat ground surface. Maknanya your footing base ni memang dah fully saturated lah. Kemudian case kedua, water table berada ZW from ground surface. Maknanya kalau ZW ni sama dengan 1 ke 2 ke, so lepas tu baru ada effect groundwater table. And then case number 3 yang mana water table lies on the same line of the base footing. Kemudian water table above the passive zone. And case number 5, water table below the passive zone. So how are we going to calculate all these things untuk you dapatkan ultimate bearing capacity? Sebelum tu saya keluarkanlah dulu untuk you kenal pasti first term, second term, third term kan. Satu lagi, kalau you tengok kat sini, kenapa kita tak pakai CNC? Kenapa kat sini kita tak pakai 0.5? Sebab soalan ni adalah square footing, dia bukan lagi strip footing. So first term kita adalah 1.3 CNC. Term number 2 maintain untuk semua jenis footing kecuali footing rectangular. Kemudian third term 0.4 B gamma N gamma. So then kita akan dapatlah QF dia. QF ni adalah ultimate bearing capacity. Okay, sebabkan kita nak kira yang pertama, kita nak jawab untuk yang pertama ni. So this table referring to the case 1 lah. Okay, table ni untuk yang pertama. Table berikutnya untuk yang kedua. Untuk soalan kedua. Okay, untuk water table ground surface, kalau tengok tadi kita punya masalah, so term number 1 sebenarnya dia akan ada effect water table lah, tapi kat sini tak ada unit weight, so dia tak kacau. So kita boleh terus calculate 1.3 darab C sama dengan berapa? 15.2 NC 17.7. So kita akan dapat 349.75. Kemudian untuk second term, sebabkan water table at the ground surface, so kita akan mengguna effective unit weight. So you akan nampak kat sini unit weight soil 17.8 tolak dengan 9.81. NQ berapa? Okey, NQ 7.4, DF founding depth. Sebab kita nak dapatkan overburden pressure efektif kan. So gamma efektif darab dengan DF. 17.8 tolak 9.81 darab 1 is the effective overburden pressure. Darab dengan NQ dapat 59.13. Okey, untuk term number 3. Okey, term number 3 ni dia berkaitan dengan unit weight. Unit weight tu pula dia merujuk kepada base footing. Base footing kita ni ada efek air tak? Kalau kata tadi water table ni daripada permukaan atas ground surface sehinggalah 1 meter, maknanya kita ni base footing ni akan ada effect of water lah kan. So dalam term yang ada unit weight ni kita tak boleh pakai dia 17.8. Kita kena buat dia sebagai effective unit weight. 17.8 tolak dengan 9.81 darab dengan B 1.5, faktor dia 0.4 dan juga N gamma is the 4.4. So you akan dapat 21.09. So the ultimate is the total up semualah. Tambah daripada 349.75, 59.13, kemudian 21.09. So you dapatlah 429.97. So I hope this one is very clear lah. Okay, kemudian untuk case number 2, yang mana water table berada 0.5 meter from ground surface. So in this particular conditions, you akan nampak term number 1 dia tak ada effect. Sebab apa? Dia tak ada effect unit weight. So kita boleh maintain carry the same value from above. Tapi untuk term number 2, sebabkan sekarang dia dah berbeza condition. Sebab air sekarang ni dia bukan berada pada permukaan tanah. Dia bermula pada 0.5 daripada permukaan tanah. Yang mana you akan ada satu condition dry, satu condition lagi, separuh lagi condition dalam keadaan wet. So in order to calculate the effective overburden pressure, dia kena ambil daripada combinations dry dan juga wet punya overburden pressure. So for the first one, 17.8 darab dengan 0.5 ini merujuk kepada overburden pressure yang tak ada efek air. Campur dengan efektif overburden pressure iaitu 17.8 tolak dengan 9.81 darab dengan 0.5. Kenapa kita tak ambil 1? Kenapa kita ambil 0.5? Sebab tadi as I said, the water table started 0.5 below ground surface. So founding depth ni bukan lagi sepenuhnya dalam keadaan wet. Separuh basah, separuh kering. That's why overburden pressure kat sini dia ada dua. Satu daripada dry condition, satu lagi daripada wet conditions. Times dengan 7.4 is the NQ. So you akan dapat 95.42. Okay, how about term number 3? Term number 3 ni dia akan ada effect water table. Sebab apa? Sebab walaupun air tu berada 0.5 daripada permukaan tanah, foundation kita below ground surface, below water table effect kan. Maknanya foundation kita ni dia ada kesan daripada air tu. So kita kena ambil efektif unit weight. So 17.8 tolak dengan 9.81. So you akan dapat 21.09. So you total up, you akan dapatlah 466.26. So the ultimate bearing capacity as you look at, it is increase lah, but somehow dia akan decrease dekat case number 4. Okay, kalau dekat base of foundations base of foundations ni you have to be careful lah. Sebab dalam case number 3 dia akan ada effect water table. Sebab apa? Kalau you tengok sini term number 1 maintain, term number 2. Term number 2 dia akan berubah. Dia bukan lagi macam case number 1 ataupun case number 2. Sebab apa yang berlaku sekarang pada case number 3, water table tu berada selari pada base footing. Maknanya bila you nak calculate overburden pressure at base footing ni, kita melihat stress pada permukaan atas dia. So stress yang datang daripada unit weight above it dalam keadaan dry condition. So that's why kat sini dia bukan 17.8 tolak dengan 9.81. Dia adalah 17.8 because it is in the dry conditions. So the water table started at the base footing. So term number 2 dia tak ada effect. Dia only affected in term number 3. Sebab apa? Water table at the same lines of the base footing. So that's why kat sini bila you nak calculate term number 3 unit weight, you kena tolak dengan 9.81. So dia akan dapat 21.09. Untuk term number untuk case number 4, case number 4 ni sebabkan dia punya water table above the passive zone, so dia punya formula dia berbeza lah, and you have to get what is the DW sama dengan 1.5. DW ni adalah influence depth dia lah from the ground surface. DW pun dia ada cara lah macam mana nak kira. I think that you pergi balik dekat nota dekat bawah tu tadi, it shows you how to calculate the DW. Okay, at this particular things. DW ni kalau you look at from this one is founding depth 1 plus dengan water table influence tu 1.5. 0.5. So kita akan dapatlah 1.5. So that's the affected in term number 3. So untuk case number 5 yang mana water table below the passive zones, so you can see that for the term number 2 and also term number 3 ni, dia dah tak ada langsung effect water table. So this is quite well below. It's quite firm. Maknanya kesan air tu terhadap base footing tu tak dirasai. So that's why lah overburden pressure tu kita pakai total. Similarly untuk unit weight pun kita akan pakai total. So that's how we can calculate the ultimate bearing capacity to all cases 1, 2, 3 and 4, 5. And then the next question asks you the allowable capacity of this footing for FOS sama dengan 4. Okay, dalam case ni kita dah calculate QF kan, so kita keluarkan semua value untuk 5 cases. Kemudian kita kena kira net ultimate bearing capacity. So the net ultimate bearing capacity is a ultimate bearing capacity QF tolak dengan overburden pressure. So overburden pressure ni pun dia merujuk kepada kesan air tadi itulah yang kita calculate. Kalau kata air tu fully from top of the ground surface, so overburden pressure kita adalah efektif gamma darab dengan D. D masih lagi kekal lah sebab founding depth tak akan berubah kan. Founding depth ni adalah berapa kedalaman korekan tanah untuk you letak footing. Maknanya footing tu bukan berada pada permukaan tanah lah. Footing berada beberapa meter daripada kedalaman ataupun daripada permukaan tanah. So dalam kes ni kita korek 1 meter kemudian baru kita letak footing. So daripada situ kita akan nampaklah the effect water table is to the whole 1 meter depth. So you akan nampak 17.8 tolak dengan 9.81 darab dengan 1. So kita dapat QNF sama dengan 4. Okay, dalam this case I calculated saya menggunakan formula sebagai QNF bahagi dengan FOS lah. This is saya menggunakan kaedah Bradas. Kaedah dia pakai this kind of formula, but dia akan bagi you overestimated the value Q net allowable lah. But I recommend you to practice menggunakan the right formula as the safe bearing pressure, iaitu QNF bahagi dengan FOS plus dengan overburden pressure. So this formula ni kalau you ada masa you recalculate balik lah what is the right ataupun the new value of safe bearing pressure according to the standard lah with law ke or any other theory. Okay, kalau kata dalam kes ni kan you are asking to determine the net loading. Berapa nilai loading yang dikenakan ke atas footing ni. So kita nak tahu berapa design load lah. Design load ataupun orang panggil intensity loading ataupun column load or design load transfer from column. How to get that ones? Okay, first of all kita kena calculate lah the area of footing. So the area of footing similar to all cases. So 2.25, kita dah dapat size footing itu berapa? 1.5 by 1.5. And then in order to get the Q, so Q net allowable darab dengan A. So the A is a area of the footing. So Q net allowable ni daripada this row. So kita darab dengan 2.25. So you akan dapatlah the net loading for different cases lah. Net loading ni adalah berapa design load yang you akan pindahkan kepada footing tersebut. Dan kita akan check lah. Makna kata dengan nilai FOS 4 ni, this is the allowable loading that you set to the footing design. So dia tak boleh exceed lah, nanti akan berlaku shear failure. Okay, yang ni adalah contoh kedua. You are asking to determine factor of safety. Factor of safety ni pun I think that from this question is quite straightforward because of dia dah bagi jenis footing circular, kemudian dia bagi information column load. Okay, the only difference from example 1 is that tadi example 1 kita dapatkan column load yang akhir sekali kan, step yang terakhir. Tapi daripada example 2 ni, you kena dapatkan size footing, circular footing from the given information column load. Maknanya back calculations lah daripada example 1. So the water table is well below the footing and take the factor of safety against shear failure as 2.5. Kemudian NC and gamma as stated here. The water table effect ada dua. First, well below. Satu lagi, kalau is a fully flooded. Fully flooded ni maknanya water table effect at the ground surface lah. Okay, how to do the calculations ataupun solutions. Okay, since it is stated that circular footing, so kita menggunakan the right formula lah, 1.3 CNC gamma and gamma plus 0.3 B gamma and gamma. Kemudian kalau you perasan sini, sebabkan kita B tu adalah unknown, so you punya Q ultimate adalah something unanswerable. Maknanya dia tak boleh jawab lagi lah, kita tak ada jawapan dia. So B is remain as an unknown in this Q ultimate. And then how to get the Q net? So yang ni pun dia menggunakan overestimation Q net lah, yang mana dia terus Q and U ataupun Q and F bahagi dengan FOS. So I forgot to tell you is that QU ni sama dengan QF lah. Ada setengah buku dia guna QU, ada setengah buku dia guna QF. So these two things are similar lah. Okay, daripada QNet ultimate bearing capacity from these estimations, dia akan dapat 712.28 plus 29.78 P. So what's the next? The next thing here is to find the P ataupun the size of the circular. So kita dah tahu Q tu tadi berapa. Kemudian kita dah tahu the area of the circular can be calculated dengan pi B square over 4. Nah, ini sekarang ni Q ni adalah intensity column design. Q sama dengan Q times dengan area. So this is exactly what we have from the example 1, yang mana kita nak dapatkan design load tu. Tadi kita buat macam mana? Q ni kita darabkan dengan area. So same goes to here lah, daripada Q allowable kita darab, kita jadikan dia sebagai Q design load sama dengan Q allowable darab dengan area. So you akan settlekan as one single equation to have the size of the circular diameter ataupun lebar of the circular footing tu. So the B is 1.51 meter. So apa tujuan dia? Tujuan dia adalah untuk kita estimate the next ultimate bearing capacity of the salt accordingly to the case 1, yang mana tadi dia sebut well below. Well below ni is a condition yang mana water table below the passive zone. Remember just now I show you that we have 5 cases. 5 cases well below ni jatuh pada case number 5, iaitu water table berada di bawah passive zone. That's why Sekejap. Sekejap. Okay, sebenarnya dia apa? Sekejap ya. Okay. I was wrong. So it is the condition that this formula is calculated. Okay, the well below is here is referring to this one. How to start answer the example 2. Soalan. Maknanya kat sini dia bagi conditions yang mana the water table effect is well below. So you can see that dia punya formula overburden pressure semua, kemudian gamma kat sini pun dalam keadaan gamma yang tak ada effect water table. So 1.3, 35, darat 31.6, 17, darat 1.2, darat 17.8. So it means that for the first calculations, untuk dapatkan the size of the footing, so you consider as well below dengan keadaan case number 5 iaitu water table below the passive zone. Okay, after you have obtained the B size, and then you want to determine because the next one asking you what would be the factor of safety if the area is flooded. So yang ni yang dimaksudkan, yang mana you have to recalculate the new ultimate bearing capacity considering the effect of the water table at the ground surface. Maknanya dia akan terkesan pada term number 2 dan juga term number 3. That's why kat sini kalau you look at to this Q ultimate is the effective overburden pressure iaitu 19 tolak dengan 9.81, 9.91 darab dengan 1.2. 1.2 is the founding depth darab dengan NQ plus dengan 0.3 times dengan 1.51 the size of the footing times dengan effective unit weight times dengan N gamma. So 1694.88. So actually this question is not solved yet. Sebab apa? Dia minta calculate factor of safety. So I give it to you to okay, kita ada beberapa minit lagi sebelum kita end this class. So I want you to calculate further what is the factor of safety from this kind of the problem, iaitu case yang mana ultimate bearing capacity is calculated with the effect groundwater table at the ground surface. So berapa nilai factor of safety using the formula safe bearing pressure ataupun safe allowable bearing capacity. So you have to use that kind of the formula menggunakan okay. Okay, I nak you calculate. Okay, what is the, sebab soalan tu minta factor of safety. Okay, kalau kita tahu Q allowable ataupun safe bearing pressure is equal to Q and F bahagi dengan FOS plus dengan overburden pressure. So the next question asks you what is the FOS. So I give you 10 minutes to calculate and give me answer what is the FOS. Can you do that? Boleh tak kira?
Boleh.
Okey, cuba kira. Okey, cuba kira berapa. Okey, dalam this case kalau you tengok kita nak dapatkan FOS. Yang ni yang kita tak tahu. Q and F boleh kira. Q and F sama dengan QF tolak dengan overburden pressure, effective overburden pressure. QF tadi kita dah kira dah untuk yang case tadi, betul tak? QF daripada kita punya jawapan 1694.88. Maknanya kat sini you boleh letaklah 1694.88 tolak dengan overburden pressure. So overburden pressure kat sini kita nak ambil case yang mana? Kita still remain the same case lah, yang mana water table at the ground surface. So if you look at to this one dia dah calculate dah effective unit weight. So you just ambil ataupun you ambil semula 9.19 darab dengan 1.2. So 1694.88 tolak dengan 9.19 darab dengan 1.2. Sebab overburden pressure, effective overburden pressure is equal to effective unit weight darab dengan the founding depth. Founding depth dalam soalan ni adalah 1.2. So effective unit weight adalah 9.19. So maknanya kita tak ada masalah lah nak calculate yang first atas ni Q and F. Yang kita nak dapatkan adalah FOS. Overburden pressure pun kita boleh kira. What is our problem next? Our problem next adalah Q allowable. But this thing kita boleh assume yang mana Q allowable kita is equal to the Q. Okay, kita boleh assume Q allowable footing soil. Maknanya sekarang kita boleh assume Q allowable soil yang beban dikenakan ke atas, beban dari structure dikenakan ke atas tanah sama dengan Q allowable daripada loading. Sebab tadi kan macam saya cakap, Q allowable ni kita tak tahu. But we can use the assumption is that Q allowable load. What is the Q allowable load ataupun the contact pressure load is the Q intensity loading bahagi dengan area of the footing. So intensity loading tadi berapa? 1.4 darab dengan 10 kuasa 3. So 1.4 darab 10 kuasa 3 bahagi dengan pi, diameter is 1.5 kuasa 2 bahagi dengan 4. So with that assumption, so kita boleh letak kat sini lah. So cuba calculate berapa? Q over A.
Tujuh 92.234.
Berapa?
792.24.
Okay, sekejap. Maknanya Q over A tu lah kan, you dapat macam tu kan? Okay, so kita boleh letak kat
doktor.
satu. Sorry again? 1 7
No, 792.24.
0.24. Okay, unit dia adalah kilo Newton per, ke dia Newton saja? Okay, look at that, the questions. 1.4 meganewton. Okay, 1.4 meganewton sama dengan 1.4 darab 10 kuasa 3 kilo Newton. Betul tak? Betul tak 1.4 meganewton sama dengan 1.4 darab 10 kuasa 3 kilo Newton? Am I right?
Betul doktor.
Okay, that's right. That's good. Okay, maknanya sekarang ni 792.24 kilonewton per meter square sama dengan okay, Q and F tadi, okay, cuba kira 1694 ataupun yalah 1694.88 tolak dengan 1.19 darab 1.2. 9.19 darab 1.2. Okey, kemudian 1694.88 tolak dengan 11. So berapa jawapan? Q and F.
1683.85.
1683.85. Okey, bahagi dengan FOS. FOS ni yang kita tak tahu. Tambah dengan 9.19 darab dengan 1.2. Because yang ni overburden pressure tau. So 1.19 darab dengan 1.2. Okay, can you solve that problem? Of course, yes. So maknanya kata nanti apa yang you perlu buat adalah 792.24 tolak dengan 9.19 darab dengan 1.2 iaitu 11.028 sama dengan 1683.85 bahagi dengan FOS. So I think that from here you dah tahu what is your FOS value. Boleh tak bagi tahu saya FOS berapa? So FOS sama dengan 1683.85 bahagi dengan 792.24 tolak dengan 11.028 iaitu 781.21. Okey, bagi 1683.85 bahagi dengan 781.21. So the FOS berapa nilai dia?
2.16.
2.16.
Oh, bagus. So dalam ramai-ramai kelas ni berapa orang je yang bersama saya ni? Kelas, come on you have to take part this one because yelah saya faham benda ni macam hari ni belajar, hari ni nak kena terus ikut, lepas tu nanti nak kena buat revision kan. But it's very important sebab macam saya cakap lah, dalam awak punya test 1, kita akan cover seluruh topik 1. Kemudian topik 2 ni kalau kita tengok dia adalah foundation plus dengan settlement. Foundation ni pula kalau kita pecahkan dia ada dua jenis. Kita ada shallow foundation, kita ada deep foundation. That's why dalam lesson plan awak dia hanya concentrate shallow foundation. So you are lucky dia tak tanya banyak tau. Dia hanya concentrate on the whole chapter 1 plus dengan shallow foundation daripada topik tu. Immediate settlement apa benda ke wallahualam, tapi dalam lesson plan tu dia just stated sebagai shallow foundations. So in terms of the revisions lah kan, apa yang you boleh concentrate, sebenarnya you can guess lah, okay kita nak concentrate dalam topik tu shallow foundation sahaja. Tengok dekat dia punya definitions, tengok dekat dia punya factor, tengok dekat dia punya shape, apa influence the segi assumptions tu apa. Itu yang melibatkan teori. Kalau melibatkan calculation macam tadilah, saya tanya you pasal ultimate, apa beza ultimate, apa beza net ultimate, and then how to calculate both things for different cases of water table effect daripada case 1, 2, 3, 4, 5. So all those things are important for you untuk you prepare test 1 yang Jumaat depan saja. So kalau you kira-kira tu berapa hari je tinggal. Betul tak? So this is the way I nak tarik you bersama-sama buat this kind of calculations. So nanti senang lah you nak buat revisions kan untuk minggu depan. Minggu depan kita tak ada online class. Kita hanya buat learning activities. So learning activities tu you ambil daripada you future, you redo balik the questions. So back to this example untuk jawapan FOS. So you are right lah. So my answer is also have same you 2.16. So maknanya kalau kita nak design footing ni, ada setengah teori dia kata 2.0 can be accepted for value FOS. Tapi ada setengah yang consider daripada 2.5 sehingga 3.0. So if you feel that 2.5 is very conservative lah ataupun you rasa macam tak selamat, you still want to get 2.5 kan. So but kalau you tak terikat dengan soalan, you can do redesign. Tapi kalau this case of problem, you are given the questions yang you terikat dengan soalan, so that is the final answer FOSU sebagai 2.16. So okay lah. Maknanya you dapat jawapan yang sama dengan jawapan saya, sama dengan skema, sama dengan soalan. Okay, is there any questions before we end?
Doktor, saya nak tanya doktor, ni berkaitan dengan attendance. Just now saya tengok doktor buat untuk tarikh esok.
Ya. Macam mana tarikh esok kan? Tak apa, nanti saya adjust balik. Sekejap. Asalnya okay, Sat. Sementara tak habis lagi dan gini. Okay, Pak Tim. Hari ni 14 20. Sepatutnya 21 20 kan?
20 doktor.
Okay, thank you for bagi tahu saya pasal ni. So nanti jangan lupa take attendance sebab you tahulah kan, kita ni ada 4 lecturer berbeza. So yang mengajar topik berbeza, yang in charge group pun berbeza. So kita akan lihat your punya attendance lah to this thing. And then kalau boleh jangan lupalah tick sebab benda yang mudah kan. I mean that sambil dengar tu, sambil-sambil tu tick lah. So far daripada record yang saya tengok ni baru 2 orang je tick attendance. Mujibo dengan Nur Aisyah. Dia macam ni tau. Kalau kata masa belajar ni, you terpaksa berkongsi device, laptop, handphone saya rasa sebenarnya dia tak ada masalah untuk you nak ada self learning without sharing. Maknanya you download apps Microsoft Teams tu dekat phone you. I think every one of you semua dah guna smartphone. Dah tak ada yang menggunakan 3310 zaman dulu. Kalau yang menggunakan 3310 Nokia zaman dulu pun dah integrate kepada latest technologies iaitu smartphone. So you dah boleh download Microsoft Teams punya apps tu. So you can attend the online lecture individually without sharing. So the last time punya issue adalah bila you macam mana kata, you join online class, you join sebenarnya tapi you join sharing device dengan kawan you. So bila kita as a lecturer, topik ataupun lecturer group tu nak semak attendance, kita ambil daripada participant list dekat MT. Nama you tak ada sebab apa, you share device dengan kawan you kan. So macam mana kita nak trace you hadir tak hadir? The only way is that you pergi ke you future, you tick. Itu kalau you orang kata apa, sharing device lah kan. Kalau you tak share device pun, you still need to go to the you future untuk buat tick. So untuk you future ni, dia akan tutup 15 minit lepas kelas tu habis. Maknanya dia akan buka 15 minit lepas kelas mula. So tak ada masalah untuk awak. Okay, kalau kata saya habis kelas awal ni pun, you still have time untuk buat ticking lah untuk attendance. So ada soalan tak?
Doktor, untuk yang apa tu test 29 bulan ni, dia kalau tengok apa tu kita punya lesson plan 9 pagi sampai 6 petang tu.
Jap tu.
Okay.
Okey, apa dia soalan? Minta maaf, ada gangguan.
Tak doktor, saya nak tanya pasal kita punya test which is kalau based on lesson plan 29 bulan 4 tu hari Jumaat which is start 9 AM until 6 PM kan. So untuk dia punya tu maksudnya dia punya lama lah, dia punya range masa tu.
Dia macam ni, maksud dia sistem tu buka daripada 9 pagi sampai 6 petang. Okay, you nak buat anytime within the system open is allowed. Tapi saya sarankan janganlah buat 2 jam terakhir sebelum pukul 6. Sebab anda diberi masa menjawab, sebab kita buat soalan kita dah set dah dia punya capability to answer within the 1 hour and half minutes. So kalau kata you mula pukul 4, tiba-tiba kan you nak upload pada masa yang sama sistem tu close. And then you tak boleh submit. So macam mana? Kita orang tak boleh nak accept. Itu maksud dia. Kalau kata sistem buka pukul 9, you are ready to answer pukul 9. Maknanya hari Jumaat tu tak ada kelas. Pukul 9 tu dah boleh jawab. Jawablah pukul 9. Ada orang mungkin dia nak jawab lepas habis kelas. Contohnya kelas dia mula pukul 9 pagi sampai pukul 12 kan. So dia tak nak jawab lagi. Tak apa. Sistem still open. But once you click open the question, the time is ticking. Maknanya masa untuk setiap individual tu berbeza mengikut pemilihan masa dia pilih untuk menjawab soalan. Faham tak?
Faham. By the way doktor, untuk soalan tu dia subjektif atau objektif doktor? Sebab kat sini dia cover topik 1 dan topik 2 kan?
Of course, dia adalah dalam level awak ni untuk kita punya ni, dia tak ada objektif, dia adalah subjektif. Dia ada teori, dia ada calculation. Faham?
Faham, which mean kita orang kena buat macam like kena hantar jugalah submission dekat e-future tu lah kan?
Betul. Betul.
Okay.
Kalau you access, memang kita akan set soalan through e-future. Unless dia mention menggunakan other platform lah. Contohnya dia bagi soft copy, dia attach dalam Telegram, dia attach dekat MT. So you kena alert lah on the date tu pada 29 tu hari Jumaat daripada 9 pagi sampai pukul 6 petang tu you kena alert. You kena alert soalan tu diberi melalui apa medium. Adakah e-future ataupun MT ataupun Telegram or WhatsApp kan. But once it is given to you, it counted you dah start menjawab dalam tempoh 1 jam setengah. Kemudian kalau kata soalan tu attach dalam e-future, once you open at 12 noon, 12 afternoon lah contohnya kan. So dalam tempoh 1 jam setengah kot, dia akan lock terus masa tu. Tak silap saya, dia akan lock masa mengikut you menjawab tu. Bukan pada sistem tu tutup. Dia lain tau, sistem tu tutup dengan sistem tutup buka dengan sistem dengan masa sistem tutup buka dengan masa you mula menjawab dan habis menjawab. Dia dua benda berbeza. Sistem buka sepanjang daripada 9 pagi sampai 6 petang. Tapi masa you menjawab bebas mengikut you punya masa kosong, masa free. Masa tak ada kelas, masa tak perlu pergi solat Jumaat. Lah ni senang kan, puasa semua kan. Tak perlu nak ambil masa makan. Cuma jangan menjawab last minute dekat pukul 6 tak sempat. Nak upload lagi apa semua kan.
Okay doktor. And doktor untuk topik tu ni memang doktor akan cover semua lah untuk test nanti kan?
Kecuali deep foundation.
Okay.
Deep foundation kita tak masuk test sebab deep foundation kita akan cover selepas raya. Okay?
Okay, clear doktor. Thank you doktor.
Okay, Assalamualaikum.
Assalam.